In this video, we're going to talk about the rational root theorem. The rational root theorem is something that helps us find the solutions of a polynomial equation. It actually finds every possible real solution. So what you're going to hear this referred to in class a lot is P's and Q's. Well, what does that mean? That's saying, hey, take the constant term, we're going to call that P. And we're going to take the leading coefficient, and we're going to call that Q. So here is what I'm going to say, hey, P is the constant in the polynomial. So the constant in the polynomial. Q is the leading coefficient. So it is the coefficient with the highest degree. And we're going to take those two, we're going to take the factors of P and the factors of Q and make a list of all the possible zeros. So we're going to make a list of all the possible zeros. Again, this is going to be a lot of numbers in most cases. So taking this example here, we have P equals 12. So the factors of 12 are 1, 2, 3, 4, 6, and 12. Now, Q in this case is 1, which is nice because the factors of 1 are just 1. So now we have to divide each P by every Q. In this case, plus or minus P over Q is just the list of the P's. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. So you can notice that this list is a lot. It's 1, 2, 3, 4, 5, 6, and the negatives. So that's 12 possible solutions. So we need a way to say, hey, how can I narrow that list even more? Well, hey, we're going to start by using P's and Q's. We're going to make a list. Now what you're going to do is we're going to find one of the zeros by using the steps below. Typically, we're going to do that if it's a cubic function only, because otherwise it can be solved by quadratic formula or factoring. If it's quartic, that means degree equals 4, so this is degree equals 3. Then we're going to find two zeros. Once you find that zero, we're going to synthetically divide by each zero we found until we get down to a quadratic. And why? Because we know how to work with quadratics. And then you're going to find the remaining two zeros. So find remaining two zeros by factoring, or all those things we've been using the past few days. Remember that the degree of the polynomial equals the number of solutions, real or imaginary. So here, we're going to have some calculator steps here for how you find those zeros. So step 1, you're going to graph the function, aka put into y equals. Oops, sorry, I only wanted the. Step 2 is on the graph screen, so on graph screen, press the button that says trace. Now, next, from our list of P's and Q's, you're going to type in the x-intercept you want to test. So type in x-intercept you want to test. And that's from your plus or minus P over Q list. Now that you've done that, step 4 is going to say, hey, if the y-coordinate, so if y-coordinate equals 0, then it is a factor / solution or 0. Remember, all those are interchangeable. However, if y-coordinate is not equal to 0, then it is not a solution. And we need to keep trying. So again, let's take that first function we did up here. It's the same one down here, and I'm going to copy down that list of p's over q's. So we had plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Now, I made my list, so I go to the calculator, and I say, hey, y equals, I want to graph this function. So clear, I want x to the third, so x to the third power. Now make sure if you have the old graphing calculator, your third power is in parentheses with the x. Plus 2x squared minus 11x minus 12. Hit graph. We need to go to the graph screen. Now, using my list of values here, I want to find one of these. Hit trace. Well, look at here. If you zoom in, so zoom in here a little bit, where do I think there might be a value? Well, hey, this looks like it hits at 3, looks like it hits at -1, and it looks like it hits at -4. Well, let's try 3, since it was the first one we said. So if you hit trace, hit 3, and enter. Well, look, y equals 0, so 3 was a solution. So now, I'm going to zoom out here. So 3 was a solution I found on my calculator. I found 3, and now I'm going to synthetically divide. Again, look at your coefficients. 1, 2, -11, -12. So I need 1, 2, -11, -12. Bring down, we got 1, that's 3, 5, 15, and 4, and 12. Again, this should be a remainder of 0 because it should be a factor. And now I need to rewrite this as a quadratic. X squared plus 5x plus 4 equals 0 because I want to solve by factoring the rest. I need two numbers that multiply to 4 and add to 5. Well, hopefully we realize plus 4 and plus 1. Again, x plus 4 equals 0, x plus 1 equals 0, minus 4, so x equals -4, minus 1, x equals -1. So we got a solution, one solution, and I knew x equals 3 is another solution. Degree 3 equals 3 solutions, tying it back to the last lesson. So let's try another one. First, we're going to list p's and q's. Well, p is 8. 8's factors are 1, 2, 4, and 8. Q is 1. So I just need to divide all of my list by 1. So in this case, it's really easy again. So plus or minus p over q equals plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So now I go to my graphing calculator, I put the new function in. So clear out, I've got x cubed, so x cubed minus 3x squared minus 6x plus 8. Graph it. And again, I'm looking to see, hey, where does it look like it hits? Well, let's pick a negative this time. I think it hits at -2. So hit trace, put in -2, and look for if it's 0. It is. So hey, x equals -2 was a solution for my calculator. So now let's go ahead and see if it is a solution. -2, bring down, we got 1, -3, -6, and 8. -2, -5, 10. By now we should pretty much be pros at synthetic division. -8 and 0. Good. X squared minus 5x plus 4 equals 0. Now I want to point out there are multiple ways to do these problems. Like if you picked a different 0 to start with, you wouldn't end up with the same equation as me in the end. But you're going to end up with the same answers. So I need multiply to get 4, add to -5. That tells me I probably want two negatives. X minus 1 and x minus 4. So I've got x minus 1 equals 0, plus 1 plus 1, x equals 1, and x minus 4 equals 0, plus 4, plus 4, x equals 4. One solution, two solutions, three solutions, degree is 3. Found them all. Alright, let's get a little bit more advanced before you try these on your own. Although you could certainly be trying these on your own already. So P equals 8. Got 1, 2, 4, and 8. Q equals 3. Now I've got 1 and 3. So now my list makes it a little bit more tricky. 1 divided by 1 is just plus or minus 1. 1 divided by 3, plus or minus 1/3. 2 divided by 1, plus or minus 2. 2 divided by 3, plus or minus 2/3. 4 divided by 1, plus or minus 4, plus or minus 4/3. And finally we've got plus or minus 8, and plus or minus 8/3. So see how our lists are kind of getting longer? Again, this is why the calculator helps a lot here. So go back to y equals new equation. We've got 3x cubed minus 8x squared minus 8x plus 8. So graph it. And now we're going to see, oh hey, when I zoom in here, none of these seem to really hit at a solid number. So I need to start saying, oh hey, maybe I should try some of the fractions on my list. Well, I'm saying, look, this is a little less than 1, but it's not quite 1 yet. So maybe we should try 2/3. So trace 2 divided by 3. And hey, 2/3 was actually an example, or an answer. So I'm going to take 2/3 and I'm going to use that to synthetically divide. So 2/3, and then I got 3, -8, 3, -8, -8, +8. Bring down 3. 2/3 of 3 is 2, -6. 2/3 of -6, well that's what? -12 divided by 3, -4. Get -12, so that's -24 divided by, it should be -8. Well, now I've got 3x squared minus 6x minus 12. So at this point, I gotta start thinking, hey, do I want to factor this? What do I want to do here? Well, I see, hey, these all have a common factor of 3, so let's take that out and see what happens. Minus 2x and minus 4. So can I get two numbers to multiply to 4 and add to -2? I don't think I can. So let's use the quadratic formula. X equals opposite of b plus or minus b squared minus 4ac all over 2a. So opposite of b. So we got our a is 1, b is -2, c is -4. So opposite of b, we've got 2 plus or minus the square root of b squared. So -2 squared is 4, minus 4 times a is 1. c is negative 4 all over 2, which equals 2 plus or minus the square root. Well, this is 4 plus 16, 20 over 2. 20 is 4 and 5, which becomes 2 square root 5. So we've got 2 plus or minus 2 square root 5 all over 2, so that's 2 plus or minus 2 root 5. So yes, this ended up being a little bit more room than I actually had here. I probably could have moved up, but I have 2 solutions here, and I had my x equals 2/3 over here. Again, it's cubic, so 3 solutions. We're good. Alright, and let's do number 4 before we send you off on your own, just because there's a little bit more trickiness to number 4. So number 4, we got to make our list of p's and q's. So p's is 4. Got 1, 2, and 4. Now you don't have to do 2 twice because it's the same factor times itself. Q, we've got 15. So we got 1, 3, 5, and 15. So remember, now we got to do our lists of plus or minus. Let's put a little divider in here. That was Q. P over Q. So 1 over 1 plus or minus 1, 1 over 3 plus or minus 1/3, 1/5, 1/15. So again, you can see our list starting to grow already. 2 over 1 plus or minus 2. Now I've got plus or minus 2 divided by 3, plus or minus 2 divided by 5, plus or minus 2 divided by 15. Again, keep going. 4, we've got plus or minus 4, and 4/3, 4/5, and plus or minus 4/15. So this is a lot of values here. Again, using the calculator is super helpful here. So taking your calculator, going, hey, all right, what happens here? Go ahead, we need 15x to the 4th minus 68x cubed minus 7x squared plus 24x minus 4. And again, we're looking for anywhere it may cross here. So I might actually have to even look even closer at this graph here carefully. It looks like I have all fractions again. So maybe I have negative 2/3. That would be something to try. These could be those really small ones, the 15ths. This one could be 1, 2, 3, 4, 4 and 2/3 or something. So again, I might want to start with doing, hey, let's test and see if negative 2/3 works. And it does. Well, what about one of the really small ones, 1/15? So trace 1 divided by 15. Well, that didn't work. So I know 1/15 is not a solution. Well, what about trying 1/5? And that works. So I just found 2 in the list that work. I said, hey, negative 2/3 works. And I have 1/5 that works. So now what you should do is synthetically divide twice. So what does that exactly mean? You're going to go ahead, you're going to start, say, hey, let's do negative 2/3. I'm going to take 15, negative 68, negative 7, 24, negative 4. Bring down the 15. And then we're going to have, that's going to be negative 10. We're going to have negative 78 here. And 2/3 of that will give us 52. Add those together, we get 45. 2/3 of 45 is negative 30. Get 6. Negative 6. And should be positive 4 to get 0. So that's not going to matter. Now, start synthetically dividing again by 1/5. Bring down 15, we get 3. Negative 75. 1/5 of that, we get negative 15, and that's going to be 30. 1/5 of that is 6. So here you've got 15x squared minus 75x plus 30 equals 0. And I'm actually going to stop here, let you do the rest. This, you're probably going to want to use the quadratic formula. So, find your remaining zeros for number 4, and then you try these last two on your own, and bring those to class so we can discuss them.